each other near immediately. Additionally, this approach can be used for output-only devices like the Azure Connect or other dumb cameras that can only output data and do not perform any processing themselves locally. These devices cannot undergo the processing of an environment fingerprint because they don't have the processing hardware, as opposed to, example, iPhone, HoloLens. In Moetsi's approach, the edge server can do all of the processing of relocalization for dumb cameras and just send the finished compute relative position results to whatever device needs those results. Next is environment digitization. The environment, of course, is what we call our static surroundings. And it's a similar problem to relative position, since both problems require mapping a static area, but environment digitization needs to go further and accurately reconstruct an environment, not just fingerprint it. This 3D reconstruction of the static base layer is a hard problem to solve, as we all know. And of the 4 problems I'm outlining today, environment digitization is probably the least helped by edge processing. For example, 60 AI is able to do unbelievably fast and accurate local environment digitization using only the RGB sensor on mobile phones. However, as with anything here, using edge processing does increase the speed of reconstruction, both because of real-time processing and also because of real-time feedback on what areas have already been covered. So there's less rework. It's also an architecture where engineers only have to implement their pipelines once on a single computing platform for the edge hardware, instead of re-implementing for each device type, like 60 AI had to for Android, iPhones. Additionally, off-device processing is the only way, again, that sensor-only devices with no processing power, referred to as dumb cameras earlier, can provide benefit. Lastly is object digitization. And we define objects as the dynamic entities in the real world, not the static ones. And there are two sub-problems that need to be solved for in object digitization. 1, what is an object? And 2, where is the object in 3D space? There's so many amazing developments in this space, of course. Microsoft Research has done incredible work with real-time, high-fidelity object digitization. The renderings are so unbelievably high fidelity that you could see the wrinkles in someone's shirt. Admittedly, these algorithms can too run locally on devices without much issue. In fact, you can argue that running these models locally is important to ensure a perfectly seamless experience with virtual objects. However, again, there are always benefits of streaming sensor data for edge object digitization. Running these algorithms on edge hardware means you only need to deploy pipelines on a single platform. And again, it allows these dumb devices without dedicated processing hardware to also provide value. So now that I've outlined those 4 problem spaces, let's drill into what we're talking about today. At Moetsi, to bite off at least a little chunk out of a huge problem space, we'd like to first and foremost start with this goal. The goal is to get developers to see the value or to want to stream sensor data to a processing server. Why? Because the computational limits of a local device will never make digitizing reality possible, at least the future that we believe in, we want to see. The only way to do all of that hard math is on a remote processing server. So how do we get developers to want to do this? Well, to make it really easy and super useful. And that's why we released the Sensor Stream Pipe, the SSP. It's our first technology, and it's the first open source modular kit of parts that compresses, streams, and processes sensor data. The SSP, Moetsi's SSP, is designed to overcome the limitations of on-device sensor data processing. By taking data processing off the device, developers will be able to run far more powerful computations on their sensor data and build really awesome, badass mixed reality experiences. In the following slides, André and my team will dive into the technology. Thank you.
Thank you, Olenka. So, as Olenka described right now, the goal behind SSP is to enable getting this data from the edge devices to your remote processing server, who could be either on the edge, like nearby where you have your device, or in the cloud where you have almost unlimited processing power. And the goal behind it is to basically encode and compress the data that you capture on your device, such as the color frames and the depth frames, transmit them through the network, and enable them to be decoded and processed at scale on the other side, where you have the much larger amount of processing power. So a quick summary of the results that we have achieved. We can achieve a substantial 20 times data compressions, where you can compress a stream that would be in its original shape of 400 megabits to just 20 megabits. This compression is achieved with very high quality, with the peak signal to noise ratio of about 39 decibels, which is what you achieve with a good quality codec, and with a very small processing overhead in the order of the 10 to 15 milliseconds. So I'll show you here. Please, Olenka, next slide. Thank you. So here you can see what it looks on the other side. So this slide by itself is not very exciting because it's static, but what is representing here is what you get on the device that's processing data. So on one side, we have an Azure Kinect DK camera that is streaming color, depth, and an IR stream simultaneously, which are these three squares with the color, IR, and depth data that you see. This is being streamed in real time from a device, and it's being received on the other side on the processing server. And from here, you can see on the small command line interface there that the data is it's being streamed in real time. So you can see that it's streamed at 30 FPS and with a latency in the order of the 20 milliseconds, including the network latency. And you can see here that this data is, the stream size was reduced from the 400 megabits to the 20 megabits, including these three streams. So these three streams are being transmitted at 20 megabits, which is something that you can achieve over a 4G or 5G network. So this amount of compression can be used in networks such not only on Wi-Fi but on mobile networks. So Olenka, if you can show the next slide, please. So SSB is a modular kit of parts that are designed to help you in building these types of services. So you have a device on the edge, such as it could be your phone. In this case, it is the Azure DK Kinect camera, that it sends the frames of the device to a remote server, and you have the processing server that receives these frames from one or more cameras and does the bulk of the processing. So the SSP is made up of three components that are designed to run on these different devices. So the SSP server is the frame encoder and sender for SSP. It gets the frames from the device or from existing data sets for depth and color data sets, encodes them and compresses them in real time and sends them over the internet or your local network for remote processing. The SSP client is the frame receiver and decoder that's working on your processing server that runs the remote processing server, getting the frames for further processing. And you also have the SSP tester that is able to show the impact of the different compression algorithms that we have available. So you can see the impact of running SSP on your data. So you can tune the parameters, choose amongst the different codecs that we have, choose amongst the different parameters for compression, more compression, less compression, faster encoder, slower encoder, more quality. So you can see the impact on this. And this is also where you can measure the peak signal to noise ratio and the differences in millimeters for depth data. So you can see and tune your parameterization before you deploy it to the field and deploy it to the real world. So Olenka, next slide, please. Thank you. So to show you how this all works, this diagram here shows you the full process behind getting a camera from an image from the camera in the real world and getting the raw frames for processing on the other side of the server. So starting from a camera, you send the raw frames to the SSP server, which can, at the first stage, will be to encode them. So what is one of the greatest things about SSP? The SSP supports multiple types of encoders for a multitude of frame types. So in addition to FFmpeg, which is the most versatile encoder that can work with virtually all types of frame data, both color, grayscale, depth, etc. It also supports hardware accelerated encoders such as the NVIDIA encoder, so you can get a real good acceleration of the encoding process if you have an NVIDIA card. And also ZDepth, which is a specialized type of codec designed to greatly compress the depth map that you can generate using a depth camera losslessly and quite quickly, and to give you the best possible compression and the best possible results on the other side. So the first step is to grab this frame encode these frames. So you grab these encoded frames and get to the network packager, which is built on top of ZeroMQ. And ZeroMQ enables you to easily get these bytes of the encoded frames and easily get it to a network package and send them over the network. So the cool thing about the ZeroMQ is that on the other side, when you have the frames that go over the internet in a standardized format that we defined, that in addition to the color and depth data, you can also send metadata and camera calibration and all the parameters that you may need to reconstruct the data the best possible way on the other side. So all this data is in the standard format. And on the other side, the network unpackager, this is running on your processing server, supports multiple parallel streams. So you can have multiple SSP servers, in this case, multiple devices, sending packages over the internet, and ZeroMQ and SSP will take care of doing this unpackaging, so getting the encoded frame data out of these network packages, but also take care of scheduling. So if you have multiple devices streaming at the same time, you can have them you don't have to worry about that because SSP will deliver them as they come. And if you have multiple frames arriving, they will arrive in a round robin way. So you can get one frame from one device, another frame from the other device, and then repeat. And it will also take care of what happens if you have a faster network. Like if it's dropping frames, SSP will also take care of that. So you can still take care of it and still keep processing your data as well as the network is able to. So on this side, you don't have to worry about any of this because SSP will basically take care of the unpackaging of the network packages and of the decoder, taking into account the different frame types that the frame was encoded, and deliver you those raw frames, those matrices of color or depth data, so you can process them on your algorithm. For example, you can run the skeleton tracking on these frames seamlessly, because for your algorithm, this will be just a raw frame with all the color and depth data as if it was just captured on the device. Also, the SSP tester basically just takes off the network part of this process and enables you to compare the raw frames that you get from one side, from the left side, to the frames that you get out of the decoder. So after encoding and decoding, so you can compare them and see how SSP affected the quality of your data in terms of, for example, peak signal to noise ratio, or in terms of mean squared error in the millimeter data for depth frames, and also the compression that you achieved. So if you can also measure how small the frame got after encoding and see how well this fits your final goal. So Olenka, if you could show the next slide. So to give you a small overview, so it's open source, built on C++ API, and you can run this. Right now, this is tuned to run on Linux devices, but it's extensible and it runs on libraries that can work with, that are cross-platform. It is able to do synchronized streaming of color, depth, and IR frames, in addition to all the metadata that associated with them. You can also, in addition, if you don't want to send the compressed data, you can also send the data raw as it arrived. It should be useful in some scenarios. It works with libav/ffmpeg, which is basically gives you an infinite amount of codecs to try out for your use case. In addition to ffmpeg, we also go and build specialized encoders based on hardware accelerated encoding to give you the fastest possible encoding and decoding time for your real-time needs. Right now, it is built to support the Azure Kinect DK RGBD camera and also some existing data sets, so you can test the impact on existing data of SSP. And also, as I said before, this metadata, such as the calibration data, is part of the synchronized streaming and of the network packages. So the calibration data for all your frames arrives on your processing server as it was sent from the device. So SSP is part of a larger ecosystem. So SSP by itself could be just right. SSP by itself just streams the data as it comes. It has no additional control. But we are building SSP into a larger ecosystem where you have a coordinator node, a coordinator process that will take care of controlling the SSP server to enable you to stream data to different applications, default processors, and take care of all this. So it's easier if I give you an example. So for example, if you have an Azure Kinect camera, you can stream the color and depth data. So you'd have the coordinator send you a start package, a start command to your device. And then the server will just send you the frames, the color and depth frames. And the broker will take care of getting these frames into a certain processor that will extract the skeleton tracking data. And this information will be sent to an application in Unity where you don't need to deal with any of this. You just need to tell the coordinator, I need to get data from a Kinect to do skeleton tracking, and you'll receive the skeleton metadata in JSON standard format, and you'll be able to use this data in your application real time without having to even have to deal with the frames. Just deal with the output of this larger ecosystem. So this is, I'll pass the word back to Olenka so she can tell you the roadmap of SSP.
Thank you, André. So yeah, next on our roadmap for SSP is to build out the interfaces for ARKit, HoloLens, and AR Core, the most popular frameworks and platforms. And we're always excited to work with like-minded people. We invite you to experiment with SSP on GitHub, however you like. And if you enjoy our work and think you could help us take the project to the next level or have any questions, please contact us, contact@moetsi.com to get involved. And in terms of related projects that fall outside of this specific scope, and we're excited to see, can we support more devices, more integrations, and experiment with more encodings or improve encoding. So that's all for today. And we're just, ready and eager to take on any questions that the group has. Thank you.
Well, thank you, Olenka. Thank you, André. I'm checking in here as if we have any other questions, but before that, can you guys tell us a little bit more about the benefits and the problems of doing an open source software? Do you actually the challenges of doing an open source software?
Now, André, if you have anything from the technical point of view.
Yeah, if you want me to ask you that. Well, the challenges in our particular case, so building an open source project is more of an opportunity than it is a challenge, because it enables us to build something that it can be used by the community. And so, for example, we did a presentation some time ago with the community, another AR community that is interested in also in these types of things, and having the code being open source enables them to quickly check what we are doing, enables them to give any feedback in real time. For example, it's much easier to have, as I said, it's more of an opportunity than a challenge, because on the other presentation, I actually remember that there was a question regarding the specific format of the network package that was being sent. So having an open source project on GitHub enables me to just quickly grab the link, send the link to the group and say, well, here it is. If you want, you can explore in more detail, but very quickly it has this, and this. And feel free to get any suggestions, anything, because our goal with this project is would be to have this to be used by people and have this become something that fit the use cases of people that have actually to that if, for example, if you want to build an application, it would be very cool for us to have you give feedback about that. Like, we want to build an application, we saw your code in GitHub, it was quite cool. It would be cool if you did this and that, and maybe we can reach an agreement there, for example. I don't know if Olenka agrees with this.
Yes, I totally agree. And I guess, you know, if we wanted to offer one challenge, right, is okay, releasing it up open source means that we can't charge anyone for this, for using it. And it does provide people value. But that's, as André just said, that's not our goal. Our goal is to have as many people using this as possible, getting people used to this behavior. It's a good behavior to have. It is the only behavior that will lead us to a future state of global digitized reality. Censored data needs to be streamed off device, right? We're more interested in what interesting things can you then do on the processing end with the sensor stream data? You know, what kind of results can we compute, or what kind of results can we send back to the developers that gives them value? And then will that value then be able to have a price tag associated with it? We're not sure. It's a completely, you know, untested business model and everything like that. But in terms of this first step, no, this is just laying the pavement for the roads in order for people to actually drive on the roads, instead of already putting up toll roads that charge people for driving on them.
Yeah.
Oh yeah, that's it. The challenge that I was talking about was exactly what Olenka told right now. Is the point that you need to balance between the time spent in the project, that we won't have money coming from it, and your personal lives. That's perfect. That's really, really perfect.
Yeah, we're big proponents of the open source community. So if you somehow are able to have the means to put together something that you could give to the public for their betterment and use, we're all for it.
Yeah. No, and that's really cool, especially when we're talking about this, let's call it the AR cloud approach that or vision that you're bringing in with the being open source. Kind of allows, well, to begin with, allows for people to start thinking about what it should be. And one of the cool things, I guess, and I'm talking a bit about what I see around me. One of the cool things about the ecosystem regarding augmented reality, regarding virtual reality, also, is that we see a lot of people that have good vibes. They are always giving, and it's really cool. And that I think happens because at this point we are all getting a lot. We are receiving a lot because we're pretty much discovering new use cases. Every day we are discovering new ways of doing stuff, and it's like an explorer's fever. We keep on wanting more and seeing a lot more, and we're the first ones to actually see stuff happening. But at the same time, it's also very important for us to act as, like, let's say, evangelists of this technology and what it can do at this point, and also allow for other people that are not, let's say, connected with the technology to start also thinking about what it is. And the cool thing about your project is that suddenly it allows for, well, pretty much any technical guy in a company to start tinkering with what augmented reality can be and how it can relate directly the use cases that you're proposing to well, their own business. And there are a lot of 5G-edge computing related AR use cases that have already been listed, but well, there are a lot more to be had, to be studied, to be approached. So overall, what I wanted to ask you, so following up on this little rant, was are you right now working with any corporates, any corporate entities, or any official entities? And are you right now supported or being supported by any entity in the research that you're developing?
Well, I'll answer that by saying that this is a relatively brand spanking new release. So the answer is no, we're not yet releasing with, or we are not yet partnering with corporates or anything like that. And that's why we appreciate forums such as your own here today, being able to get up on a megaphone and talk about what it is that we built, given that this has just recently been built. And the more we can participate in these kind of forums, the better we can get the word out, and the more we could accelerate our plan to work with these bigger enterprise units.
Yeah, because one of the cool things, but at the same time, one of the scary things about big corporates is that, well, sometimes they don't know, and sometimes they know a lot in a way that they feel that they need to like create walls. So that's pretty much what I think needs to be also well talked about. Interoperability between the several let's call them AR clouds. You talked about 6D, yeah. So spatial anchors. Well, pretty much all these big brands right now have a lot of let's say walled variety gardens where they have their own well, pretty much their own pictures of reality, so their own scans. And one of the main things that I think it's really interesting to also pop up and start realizing is how are we as users going to, well, to start with, create or push for this interoperability to happen, because well, of course the manufacturers will try and keep them as close to them and all the data close to them as they can. And also how can we actually push for our privacy, right? And how can we make our privacy happen in a world where we are accepting that everyone has a camera and everyone is scanning everyone and all the world with a camera. So yeah, I don't know, what are your thoughts on this?
Yeah, well, look, when it comes down to the walled garden, as you mentioned earlier, that's exactly the opposite of what we're trying to do. We're trying to eliminate those barriers, and precisely that, right? Let's say that you're part of a big team, a development team at a bigger company, and the last thing you want to do is get approval from licensing somebody's proprietary streaming pipeline or something like that. Really, what we want people to do, and what we find is very beneficial, is that they stumble upon an open source nifty tool that gets them to where they need to go, and they themselves evangelize this tool across either their teams or other teams, and that's the idea here. And the second piece that you mentioned about privacy, yeah, no one in this meeting today is necessarily wearing the hat of being our spokesperson on privacy and how we're planning on handling it today. That's something that we think of every day. It's very top of mind, but we do not yet have kind of the expertise right here on this call to be able to speak intelligently about that.
Sure. Now I just push that that topic because sometimes when I bring in the open source debate, and I work at a tech consultancy, so sometimes I do that, and sometimes I hear, well, okay, yeah, but open source is not that. Sometimes it's not as safe as proprietary code, and that. Well, that doesn't make sense to me in just one way, but I would like to hear a bit about what you think about this, especially because, well, right now we're talking about people literally hacking into what you're seeing, right? Hacking into your point of view on stuff, onto your memories. So what do you think? Do you think that the kind of the level of safety and security that an open source solution like yours provides is similar as a proprietary one?
Well, as it stands today, no. Right? Like I mentioned earlier, this is a new release, and we're just so happy that it works and it provides the results that we projected for it to provide. As you spoke about earlier, being able to build something open source is a luxury. You have the time, you have the resources, right? So no, we don't have the big corporate funding on our back to be able to run multiple initiatives in parallel, one of the initiatives being privacy concerns. And one day, hopefully, we will have that luxury. But today, just getting it to work, first and foremost, was the first protocol, at least for this release.
Okay, yeah. Well, and again, I just sometimes find it odd that people feel that it's well, again, not that that safe as a principle, because well, again, open source kind of is a basis on top of which, if it's well done, then you can do pretty much whatever you want, and then prepare everything in a way that well, you can make it safe. So it's not like a black box that you just click on the button and it starts working, of course, but it's something that in a way allows for people to, well, develop and their custom solutions in a cleaner, safer way, and again in a way that also helps the community and pretty much everyone else that is around them. So yeah, it's really cool stuff. So what are the next steps then for the project?
Yeah, just being able to extend it to multiple interfaces. AR kits, very top of mind, is the next step here, right? And supporting just more support so that when people stumble upon this, it's not just for a very narrow use case, and they can actually extend it to the more popular use cases.
Your guys are more focused on AR than VR, or both of them?
AR, correct.
Yeah. What kind of events would you be interested in? Like, for instance, hackathons? Would you be interested in participating and cooperating with universities, with students, with researchers?
Oh, absolutely. All of the above.
Okay.
We really appreciate this opportunity to give us a megaphone and announce ourselves and announce what we've built. So thank you very much. And any similar opportunities are well welcomed.
Yeah, even more, right? Because right now you have a cool thing that works. So it's also, it would really be cool for pretty much pick that up and put in the hands of people so that they can tinker with. So that the hackathon part was just an idea.
Great idea. Thank you.
Yeah, and I'm not throwing the idea. I'm actually trying to think about ways for us to continue helping.
Oh, great! Well,
because we have so the community is well, overall in Portugal, it's for the size is not that it's not that small. We are kind of a small country, but right now we identify that the VR AR Association in Portugal around 100 companies that have either 50% or more of activity doing VR AR interactive development, or like big corporates that have a VR or AR specific department. So we're talking about, like, for instance, Siemens has its VR AR global initiative coming out of Portugal.
Oh,
so,
wow.
Yeah.
And so yeah, please, if you want to leave this up, have anyone reach out to us on our email address, and if any other forums come up, hackathons, we are very eager and excited to be involved. So thank you.
Yeah. So it's a big I'll also try and do a shout out with within the university partners that we have. So we have several universities that also connect with us to see if they would be interested also in passing on the contact. Overall, you should also be aware that during this year, I think there will be some programs, some launched by big corporates, telcos and all, some launched by the government on to support 5G and edge computing use cases. And well, this could be really cool. So yeah.
Thank you.
A lot of yeah. So
Thank you so much for your time today and for the great questions. Appreciate it.
Absolutely. Meanwhile, I'm just going to do maybe, I don't know, Inés, are there any other questions?
No, please, not for now.
Okay. But I'm just going to do a quick presentation of the VRARA.
Oh, great.
It's really quick. I hope if I kind of find the of course, oh, it's here. I thought I had lost it, but it's still here. So yeah, so I'm just going then to do a share. Where are you? Here you are. Can you enable my sharing, Anesia, please? See if and now I can. Okay, so probably now you can see. So yeah, so here we are, the VRAR Association. So it's going to be really quick this time. So the VRAR Association, it's well, probably the largest virtual reality and augmented reality professionals association. So our main focus is to provide growth, knowledge, and connections, which translates into, well, provide opportunities for business to happen, to companies, knowledge in a way that we exchange best practices, in a way that we exchange also use cases and business cases, and we also make that available to all the members. And we believe networking can actually accelerate also all of our activity and also all of our knowledge. So hence it makes sense for us to do that. In numbers, we're talking about, well, right now above 4,500 companies, brands, and schools that interact throughout more than 50 countries. So right now we have 70 plus chapters. We organize, so all of the professionals, all of the companies organize themselves into industry committees. So for instance, I am part of the enterprise committee. There are some of other members that are part of the tourism committee or the retail committee. And pretty much what we do, besides doing like two calls every 2 weeks, we create reports, best practices reports that then we share with, well, pretty much all the members across the globe. And some of these reports get published on Forbes and yeah, other North American magazines. Actually, this VRAR Association is a North American association that right now is pretty much all around Europe. You can see it here. So it's, well, Northern Hemisphere, of course, but still very spread out. And yeah, so we're talking about a really cool thing, which is having a community that works. So we're talking like we're talking about a Slack channel that right now I can tap into, and I can start talking to several professionals from well, the time zones that are available right now. But like later on, I will be able to talk with people from yeah, Hong Kong, from people from Vancouver, from yeah. So and really early tomorrow, I will be able to talk to people from India, from China. So that's the cool thing about the, well, the global association. And besides that, there are a lot of trainings and well, webinars also, and yeah, we have also a lot of events that we try to promote. So to relate directly with us, you don't need to be a member, although you can be a member, and there are several membership levels. Still, we, as a local chapter of the VRAR Association, our main focus is to develop the ecosystem, and in that sense, we try and create and leverage the ecosystem as a whole. Also because, well, we're small again, so it makes a lot of sense for us to again create and take the most of the synergies that we can develop. So as you can see, there are a lot of yeah, big members from the VRARA, and also smaller companies. So it's, yeah, a very different level of companies, and the member value is pretty much here. So yeah, overall, just to let you know that if you want to know a bit more about what is being done on virtual reality and augmented reality, not just in Portugal, but across Europe and pretty much all over the world, you are more than welcome to reach out. You are also more than welcome to ask us about, well, companies or members or professionals in Portugal, because, well, pretty much we are in touch with what's happening. And also yet another thing which we are right now doing is also trying and, well, I wouldn't say organize, but try and make some training happen in order for people to actually interact with augmented reality topics in a way that is well, simple and more straightforward, let's call it like that. So not just augmented reality, also virtual reality. So we are now trying to organize along with key partners like APDC, which is a company that, or sorry, association that we connected earlier this month. So we started a partnership with them. And APDC is the association for the telcos here in Portugal, pretty much the development or the advancement of communications in Portugal. And right now we are also working with them and other associations in order to provide more knowledge and provide more training in this area. So if you are fond of this, if you are looking towards knowing a bit more about what VR, AR is, if you want to get into the action, get into this professional scene, you are more than welcome just to, well, give us a buzz. And yeah, and meanwhile, thank you all.
Thank you. Yeah, that's great. Thank you very much for sharing that with us and for giving us this time. Appreciate it.
Absolutely. Thank you. Thank you also, André, for doing a great presentation that we needed. We need to have like more technical stuff in our webinars. It's a very important part, and it's very important also to try and bring in people that usually don't connect so much with these webinars. So we need to yeah, make people also talk tech about VR and AR. Sometimes it's not that easy.
Yes, thank you, André. You're the best.
Yeah, just for
Thank
you
for the opportunity.
Olenka and André, just for you to know that this webinar will be available in our social networks.
Oh, cool.
So
thank you.
If you need to get the link later, just go to our social profiles and get the link then.
Yeah, and I'll share and retweet and all that stuff. Thank you.
Yeah, and we are going as well as sharing this through our mailing too. So again, thank you very, very much for being here with us.
Yes.
We will share your contacts, as you said, as you gave it to us. And if anybody wants to get in contact with Moetsi, just follow them. They are a really, really nice tool in development.
Thank you, everyone, and have a lovely rest of your week. Again, for the opportunity. Cheers.
Okay, thank you very much, guys. See you.
Oi? Foi toda a gente.